Okay, welcome back. Now we're going to go over some definitions. And so this is going to be, we're going to start Gauss's method, but before we start Gauss's method and go into that, definitions are in order, so some terminology and definitions. We always start with definitions and vocabulary and terminology to basically set the foundation of what we're going to be talking about. So here we go. So in this definition, we're going to talk about linear combination. So when we talk about a linear combination of x1 through xn, these are the variables, okay? So what we're saying is we can add up add up those variables with certain coefficients, right? So we're going to multiply each one of those variables by a particular coefficient, and that'll give us what we call a linear combination. Okay, so that's what we mean by a linear combination of x, or x of 1 through x of n. Okay, so we're going to basically write them as a sum where a sub 1 through a sub n are the coefficients. They're numbers that are real numbers, so these are real numbers that are coefficients. Okay, so we call a1 through a sub n coefficients of the linear combination of x, 1 through x of n. Okay. The other next definition is a linear equation. Well, if we take a linear combination of x, 1 through x of n, and we find that that's equal to some constant, then we've created a linear equation. Okay, so notice that all of the variables have a exponent of 1. Okay, so this is a linear combination. This is a linear equation because we're setting it equal to some real number that's a constant, d. Okay, so that's what this is saying here. So that is what we call a linear equation. Okay, in the variables x1 through x of n. Okay, and then an n-tuple. An n-tuple, let's say an n-tuple, and again we usually do n-tuples or triples. N-tuples are usually put together in parentheses. So all of these numbers, right, so these are all real numbers, s sub 1 through s sub n, so they're real numbers in this nth dimension we'll talk about later on. But this is the way we write an n-tuple, right? So an n-tuple is a solution of or satisfies this linear equation if, when we substitute in the numbers s sub 1 through s sub n for the variables, it gives a true statement. Which means that if we go ahead and substitute in, instead of having x1 through xn, we substitute in for these numbers, and we take all of these products and add them together, that sum of products, if that equals d, gives us a true statement, then what we would say is this n-tuple, s1 through s of n, satisfy the linear equation, or is a solution of the linear equation. Okay, now the last part of the definition is we now define a system of linear equations. Okay, so if I have a system of linear equations, okay, oops. Okay, so let's do this. So let's say I have something like this. Let's do this. Oops. Call this D1. So there's one linear equation. In fact, what we'll do here, actually, you know what? Because we're going to have rows and columns. Let's do this. We're going to do 1 comma 1. So this is row 1 column 1. So this is going to be the coefficient for row 1 column 1. And this is going to be row 1 column 2 and row 1 comma n. And then what we'll do here is now we're going to go to the second row, and so now this is going to be our second linear equation. So we're going to have A2, 1, right? Second row, first column, and then we're going to do the same variable, right? So these are going to be linear equations of the same variables, x1 through x of n. So we're going to have this, and then we'll have A2 comma 2 for second row, second column, times the variable x of 2 plus dot dot dot, and then we'll have 2 comma n times x of n equals d sub 2, okay? And then if we continue on in like fashion, right, then we'll end up with what? We'll have a sub m, let's say, comma 1 times x of n plus a sub m comma 2 times x sub 2 plus all the way to a sub m comma n times x sub n equals d sub m. Okay. Now, this is what we call a system of equations, and the n tuple, s sub 1, all the way through s sub n, so this n tuple would be a solution to the system of linear equations if this n tuple satisfies all of the system of equations, all of these linear equations. If this n tuple satisfies all of them, which again means gives them all true statements all the way down, then we would say that it is a solution of all of the equations. Okay? And that's it.